Hello and welcome to this session on what is TensorFlow. Today we're going to see what is deep learning very briefly, and then we will talk about what are the various libraries that are available for developing deep learning applications, and then we will focus on TensorFlow and what are the various advantages, why we should use TensorFlow, what is TensorFlow, and then we will talk about what are tensors, which are, as the name suggests, TensorFlow consists of tensors and then they are executed in a certain graphical format of flow, like a graph, and that's why it is named as such, TensorFlow. And we will see how to write programs in TensorFlow. The programming language, of course, will be Python, but there is a certain way in which you write a deep learning application or a program in TensorFlow. So we will take a look at that. This is a basic introductory session for beginners, and then we will see one implementation of TensorFlow code, one full end-to-end, and that's pretty much it, what you can expect from this. Quickly wanted to mention that there are certain prerequisites before you actually go through this. The expectation is that you at least have some idea about some programming language and preferably Python. If you know Python, absolutely it will be much easier to understand the code as such. But even if you know any other programming language, I think it will be okay, and you will at least be able to understand the Python code. In addition to that, this also involves, especially the case study or the case implementation, you will be able to understand only if you have some idea about machine learning. So in case you are very new to machine learning and Python, everything, then it may be a good idea to check other tutorials that we have uploaded on, let's say, about Python and also about machine learning, so that you get a basic understanding and then come back here. Otherwise, it may be very difficult to understand this tutorial. Alright, so having said that, let's get started. So what is deep learning? Again, this video is not about deep learning, but there are other videos we have created in detail about what is deep learning. In this video, we'll just touch upon the basics, so that's like a nice segue into TensorFlow. So deep learning is in a way a subset of machine learning, and we use primarily neural networks in deep learning, and the underlying technology behind artificial intelligence is deep learning. And here we teach them how to recognize, let's say, images or voice and so on and so forth. So it is a learning mechanism, but here, unlike traditional machine learning, the data is far more complicated and far more unstructured. Like it could be primarily in the form of images or audio files or text files. And one of the core components of deep learning is neural network. And a neural network somewhat looks like this. There is something known as an input layer, and then there is an output layer, and in between there are a bunch of hidden layers. So typically there would be at least one hidden layer, and anything more than one hidden layer is known as a deep neural network. So any neural network with more than 3 layers altogether, right, is known as a deep neural network. All right. So what are the functions of the various layers? Let's take a quick look. So the input layer accepts the input. So this could be in the form of, let's say, if it is an image, it could be the pixel values of the images. So that's what the input layer does. And then it passes on to the hidden layers. And the hidden layers in turn perform certain computations. And they have what is known as a part of the training, they have these weights and biases that they keep updating till the training process is complete. And each neuron has multiple weights and there will be one bias, and these are like variables, and we will see when we go into the TensorFlow code what we actually mean by that. And so that's what the hidden layer does. It does a bunch of computation and passes its values to the output layer, and then the output layer in turn gives the output. It could be in the form of a class. So for example, if we are doing classification, it tells us which class a particular image maybe belongs to. For example, let's say if this is a image classification application, then the input could be a bunch of images of maybe cats and dogs, and the output will be like, it will say, okay, if this is activated, this gives a 0 and this gives a 1, that means it is a cat. If this gives a 1 and this gives a 0, that means it is a dog. So that is a kind of a binary classification, and that can be extended with multiple neurons on the output side to have many more classes, for example. Or it can also be used for regression as well, not necessarily only classification. Again, since this video is not about deep learning or machine learning or neural network, we will probably not go into a lot of details, but you can check other videos where we have given a lot more details about neural networks and deep learning and so on. So in order to develop a deep learning application, how do you go about? Primarily, there are 2 or 3 components that are required in order to develop deep learning application. You need obviously a programming language. So typically Python is used, and that's what we are going to use in this particular video, but you can also use other languages like Java or C++ and so on. And there are some libraries that are readily available and primarily for doing machine learning and deep learning programming. So these are a list of libraries. These are by no means the exhaustive list, but some of the most common ones like Keras, Theano, TensorFlow, and so on and so forth. TensorFlow has nowadays become very, very popular. This is developed by Google, and it is an open source library. And Keras was there before. Now Keras has actually now become a part of TensorFlow as well. So it is one layer above TensorFlow. So in that sense, they are well integrated. So a combination of Keras and TensorFlow is pretty good. Then of course you have Torch and DL4J and so on and so forth. So there are multiple libraries, but this video is about TensorFlow, and we will be focusing on TensorFlow. What are the benefits of TensorFlow and what are its components? And towards the end we will show you a code in Python. We've written a code in Python. By the way, TensorFlow can be used with multiple languages. It supports multiple languages, though Python is by far the most popular language. So let's take a look at what exactly is TensorFlow and why we are so excited about TensorFlow. So TensorFlow offers APIs. Now we can earlier when these libraries, none of these libraries were there. Even then people were doing machine learning and deep learning and so on. But the coding mechanism was much more complicated. What these libraries like TensorFlow offer is they provide kind of a high level API so that we don't have to go really deep into writing all the stuff that is required, let's say to prepare a neural network and to even configure or even to program a neuron and so on, right? So these are done by the library. So all you need to do is they offer a higher level API. You need to use that API and call that API and maybe pass the data, and that would it's much easier rather than actually going down and writing everything by yourself. So TensorFlow, that way it offers APIs to write your code in Python or even C++ and so on, other languages, Java as well. It has an integration with R as well, apparently, okay? And it supports CPUs as well as GPUs. Now, deep learning applications are very compute intensive, especially the training process needs a lot of computation. It takes very long, as you can imagine, because the data size is large and there are so many iterative processes. There are so much of mathematical calculations, matrix multiplication, and so on and so forth. So for that, if you perform these activities on a normal CPU, typically it would take much longer, but GPUs are graphical processing units. You must have heard GPUs in the context of games and so on, because where the screen needs to be of high resolution and the images need to be of high resolution and so on. So GPUs, as the name suggests, graphical processing unit, were originally designed for that. But since they are very good at handling this kind of iterative calculations and so on, now they are being used or leveraged rather for doing or developing deep learning applications. And TensorFlow supports GPUs as well as CPUs. So I think that's one of the major advantages of TensorFlow as well. Now, again, what is exactly TensorFlow? It's an open source library developed by Google and open source, and primarily for deep learning development. But TensorFlow also supports traditional machine learning, by the way. So if you want to do some traditional machine learning, we can do it. However, it is probably a bit of an overhead to use TensorFlow for doing traditional machine learning, and this is really good for performing deep learning activities. And again, if you want to get into more details about what's the difference between machine learning and deep learning, there is another video about it. You can probably take a look at that video. What else? It is developed originally for large numerical computation. So originally when TensorFlow was developed, they never thought of it as keeping deep learning in mind, but ultimately it so happened that it's really very good for deep learning development, and therefore Google has open sourced it. And TensorFlow, as the name suggests, the data is in the form of what is known as tensors. These are like multi-dimensional arrays, and they are very handy in handling large amounts of data, and we will see that as well as we move forward. And then of course the execution mechanism is in the form of graphs, so that makes it much easier to execute this code in a distributed manner across a cluster of computers and and also using GPUs and so on and so forth, right? So that's a quick overview about what is TensorFlow. We will see a little bit more detail the two major components, that is basically the tensors and the graphs. Let's take a look at what they are. So what are tensors? Tensor is, as I mentioned earlier, it is like a multi-dimensional array in which the data is stored. Now when we are doing deep learning, especially the training process, you will have large amounts of data, and the data is typically in a very complicated format, and it really helps when you are able to use this or store it in a compact way. And so tensors actually offer a very nice and compact way of storing the data, handling the data during computation. This is not really for storing on your hard disk or things like that, but in memory when you're doing the computation, tensors are really very handy in terms of keeping the data compact, because they are like multi-dimensional arrays. So the data is stored in tensors, and then it is fed into the neural network, and then you get the output. Alright, so there are some terms associated with tensors. Let's get ourselves familiarized. One is the dimension, and another is the rank. So what is dimension? Typically dimension is like the number of elements in a way. So for example, this is a 5 by 4 dimension tensor, and then you can have again multi dimensions, right? So this can be like 3 by 3 by 3. So that is the dimension. And then you have ranks. What are tensor ranks? Ranks are basically, traditionally we would have thought of as dimensions. That is actually, in this case, it is called rank. So it becomes easier when we see examples. So a tensor's rank is supposed to be 0 when there is only one element. We also call this as scalar. So just one element, and this is not really a vector, it's just an element like 200. It's also known as a scalar. So such a tensor is supposed to be having a rank of 0. Then you have, let's say, a one-dimensional array. This is a vector with a row of elements. This has rank of 1. Now if you have traditionally what we call as two-dimensional, like a matrix for example, then the rank is 2, and in this case the rank is 3. And it can have more ranks as well. As I mentioned, it is like a multi-dimensional array, so you can have rank 5, 6 and so on. Okay, so those are the terminologies in TensorFlow terms, dimensions and ranks. So this is just to make sure that we are speaking the same language, so whenever we talk about the rank of a tensor, you understand what exactly is meant by that. Now, in addition to tensors in which the data is actually stored, alright, so the data is stored in the tensors, and then once you have the data, there is a computation that needs to be done. Now the computation happens in the form of graphs. So what we typically in a TensorFlow program, what we do is, it's not like traditional programming where you just write a bunch of lines and then everything gets executed in sequence. Here we prepare graphs, various nodes, and then these are executed in the form of a session, and they use the data from these tensors. Now I know this is a slightly new concept for a lot of you, so it may be a little difficult to probably understand in the first cut, but when we look at the code, when we go into the tutorial, the code walkthrough, I think that time it will become much clearer as well. But to start with, just we need to keep in mind that we have to first prepare a graph, and when you're preparing the graph, none of the code is actually getting executed. You write the code to prepare the graph, and then you execute that graph. So that's the way, by creating a session, that's the way TensorFlow program works. So, and each of these computation is represented as what is known as a data flow graph. And we will also see that whenever you start TensorFlow, when you create an object, TensorFlow object, there will be what is known as a default graph, and then if required, I know probably in the beginning it may not be required, but in more advanced programming you can actually have multiple graphs. Instead of the default graph, you can create your own graph and have multiple graphs and use it as well. But there is always, whenever you create a TensorFlow object, there will be a default graph, and this will be very nicely illustrated in the example code that we will take to explain this. So there it becomes much clearer than in these slides. So the graph gets executed and it processes all the data that we are feeding. All the external data will be fed in the form of what is known as placeholders, and then you have variables and constants. Again, this will also become clear when we take a look at the code. And once you have the graph, then the execution can be enabled either on regular CPUs or on GPUs, and also in a distributed mode, so that the processing becomes much faster. As I mentioned, the training of the models in deep learning takes extremely long because of the large amount of data, and therefore using TensorFlow actually makes it much easier to write the code for GPUs or CPUs and then execute it in a distributed manner. So this is how the TensorFlow program looks. So there is you need to build a computational graph. That's the first step, and then you execute that graph. So the first step is to write the code for preparing the graph, and then you create what is known as a session, and then in that session you ask the session to execute this graph. So this will again become much clearer when we look at the code. Now, what are the various elements of a TensorFlow program? As I mentioned, TensorFlow program is slightly different from regular programming that we do. So even if you're familiar with Python, this may still be new for you. The way you write a TensorFlow program is different from the regular Python programming that you would have done, or even machine learning program. You would have written some machine learning program using scikit-learn or regular Python libraries. This is different from even that. So let us see what are the various elements. So first of all, the way we handle data inside of a program itself is a little different from how we normally do. In a normal programming language, a variable is a variable in your program, right? So you have anything that can keep changing, you just create as a variable, or even constants in fact are actually created as variables. But in TensorFlow, the storage in the program consists of three types. One is constants, another is variable, and the third is a placeholder. So, and there is a lot of difference between these types, and we will see how they vary and how they are used and so on. So constants are like variables which cannot be changed. So for example, if you define a constant like this is how you define a constant, by the way. The simplest format is like this, like for example, b is equal to tf dot constant, and then you give a value here. A slightly more advanced version is you also specify the type. So you say tf dot constant 2.0 tf float 32. So the type is of type float. Now, in case of constants, you cannot, during the computation, you cannot really change these values. So for example, if you want to change the value of b from 3 to 5 or any other number, it is not possible. So that is the meaning of constant. Alright, so then we have variables. So variables we are all familiar with. What are variables? Whenever we use programming, we use variables. So this is pretty much the same. This is the way you define variables, tf dot variable. Now, one thing you need to note is this is the only type in which we have v capital. Okay, constant has c, small c, and placeholder as small p, but variable has capital V. And tf dot variable, and then you give a value, and then you can specify what is the type, and then you can use the variable, change the variable at any point in time with a different value and so on. You can update the variable and so on. So we will see all of this in the code. I will illustrate how a variable is defined and how it can be changed, whereas a constant cannot be changed, and so on and so forth. And then we have placeholders. Placeholders are really a special type, and this may be something completely new for many of us who have been doing programming, but in TensorFlow this is a completely new concept. So this is very important to understand this. Placeholders are like variables, but only thing is that they are used for feeding the data from outside. So typically when you are performing some computations, you need to load data from a file or from an image file or from a CSV file or whatever. So there is a provision with this special kind of variables which can be fed in a regular basis, because one of the reasons for having this kind of provision is that if you get the entire input in one shot, typically it may be very difficult to handle the memory and so on. So I think that was the reason they came up with this mechanism where you can feed in batches. And there is a certain way of populating the placeholder. We call this feed underscore dict, and this is a parameter name, by the way. And you feed the placeholders, right? That is the meaning here. So there is a certain way of feeding the placeholders, and we will again see this in the example code as we move forward. Okay, so there are three types. One is the constant, which cannot be changed once you assign a value. Then you have variables, which are like normal variables we are all familiar with. And then you have placeholders. This is primarily for feeding data usually from outside, but of course you can also, for temporary testing purpose, you can feed within the program as well. But primarily the purpose of a placeholder is to get data from outside. So alright, so those were the constants, variables, and placeholders. That is how you handle data within a TensorFlow program, and then you create a graph. And once you create a graph, then you have what is known as a session, and then you create a session object, and you create a session, and then you run a particular computation or a node or an operation. And so typically what you need to do is every variable or a computation that you perform is like an operation or a node within a graph. So initially the graph will be what is known as the default graph. The moment you create a TensorFlow object or TF, this TF here you see, this is the TensorFlow object. And again, in the code, when we go into the code, it will become much easier to understand. So when you create a TensorFlow object, there is like a default graph which doesn't have any operations, no nodes or anything like that. So it's like a clean slate. The moment you assign variables or constants or placeholders, each of them is, in TensorFlow terms, it is known as an operation. Again, you need to get familiar with these terms, and they are not very intuitive. This is not really an operation. You're just creating a constant or a variable. And this C is equal to A into B would traditionally or would intuitively be an operation. Here you're actually performing an operation. But in TensorFlow terms, each of these, everything is an operation. So if you're creating a constant, that is an operation. Another constant or variable, that's an operation. So you can actually run each of these, and they're also referred to as nodes. And when you're in your session, you will actually run each of these. You can potentially run each of these nodes. Okay, so a typical example would look like this. So you have two constants created. A is equal to tf.constant, its value is 5, b is equal to this, and then you say c is equal to a into b, and then you create a session. Now remember, all this, you're just creating a graph. At this point, no execution has happened. All right, so only at this point, once you create a session and then you say session or ses.run, C is when actually this whole thing will get executed. All right, so that is a different way of programming compared to our traditional way of writing programs. So you need to get used to this new format. And when we look at the code as we move forward, and when we look in the Jupyter notebook, it'll become much easier probably to understand this rather than in the slides. So these are the slides showing the code. But what we can do is go straight into the lab and take a look at the various examples that are there, and starting from the very basic one, how you create variables. And so these are some of the slides that are showing. So this is about how to create variables, how to create constants, and the variables or constants can also be strings. So this is like our first hello world program, and we will talk about placeholders, how to define a placeholder and how to execute and populate the placeholder values into placeholder. We will see these examples in the lab. Actually, I will run the code, and we will also perform a small computation of adding and multiplying these variables, and we will, in the end, we will take up a use case implementation using TensorFlow. So let's first go and see those examples and then come back and I'll explain this use case, and then we will execute the use case in the lab. So let's go and check our lab. Okay, so I'm in the Jupyter Notebook environment, and this is one of the development environments we can use. This is regular Python. Anytime you do Python programming, we use Jupyter Notebook, or there are other ways of using other tools like PyCharm and so on. But for this particular tutorial, I'm comfortable using Jupyter Notebook, so I will show you in Jupyter Notebook. So this is the very basic example to demonstrate how to create variables and constants and placeholders, and what is the difference between them, how they behave, and so on. And as I mentioned, the assumption here is that you know at least some basic Python programming or some programming language, so at least you understand the code here. And first two pieces of code, you will not need a machine learning background, but when we do the use case or the case study, there it is expected that you know at least some basic machine learning concepts. So in case you need to brush up the machine learning part, you may have to do that before you go to the third one. But here, just at least some idea of programming will be sufficient. So what are we doing here in this particular line or in this particular cell? We are importing TensorFlow TensorFlow. It is, as I mentioned, it is a library. So we are importing TensorFlow and we are calling it TF. So this is just a name. You can give it any name, but it is very common and everywhere wherever TensorFlow programming is done, it is always named as TF, but you can name anything actually. Okay, so this will import the TensorFlow into my session. Now this is the way to create a variable. So let's start by creating a variable, and this is the name of my variable. I'm starting by giving a name called 0, and I say 0 is equal to tf dot variable, and then I'm giving the value of the variable here. So this is the very basic way and the simplest way to create a variable. We will see a little later there are other formats as well, but the bare minimum way of creating a variable is this. So I'm creating a variable by the name 0, and as I mentioned, you need to pay attention to the capital V here. In case of variable, it is a capital V, uppercase. Constant and placeholders are lowercase. Now I'm creating a constant, and the constant I'm naming it as 1, and the way to create a constant is tf dot constant, and then you give the value of the constant. So the value of the variable here is 0 and the value of constant here is 1. And again, constant you can also have additional parameters like a name and so on. Probably you must have seen in other tutorials or in other places where the code is written, but the basic format to construct to create a constant is this. This is sufficient to create a constant. So I created one variable and one constant. Now what else can we do? Again, here there is no real execution happening. We are just building a graph. We have not yet executed any TensorFlow code. We are building a graph, and I will show you how the graph looks as well. First let us understand the constants and variables and so on, and then I will show you how the graph is generated and so on. So what I want to do here is I want to add 0 and 1 and put it into a new variable called new value. So what I do here, TensorFlow offers these methods like add, assign, multiply, or you have matrix multiplication, matmul, and so on, right? So I will use one of those methods, which is tf.add, and then pass these two as parameters. So we can add a variable and a constant. There are no restrictions on that. So this is a variable and this is a constant. So if I do this, it will be okay. I did not execute this code, so it is giving an error. Now we are good. Okay, so what it has done is new value will be equal to tf dot add 0 1. So then we have one variable and one constant. Now let's say I want to change the value of the variable, because that is possible, right? So we want to change the value of the variable to something, some new value. So we have, in this case, new value has 1 because we added a 0 and a 1. So new value has 1. Now I want to assign this to this originally what we called as 0. So I will call that as update is equal to tf dot assign. So assign is basically changing the value. So that's what we are going to do here. Now it has not complained. We'll just say fine, right? There are no issues. Now let us try this something similar with this 1 as well. So 0 is a variable, so we were able to change the value, and we will, in a little while, we will see what exactly those values are. But before doing that, now let's say I will uncomment this part and I want to do something similar for my constant, right? 1 is a constant. Now I want to, let's say, change the value of the constant and make that also something different. Okay, so if I execute this piece of code, it will give an error. Now again, the error message may not be very intuitive. This doesn't say that you cannot do this for a constant. It will just say tensor object has no attribute assign. Now that sometimes may be confusing, especially when you're starting. But the meaning here is that 1 is a constant and you're trying to modify the constant, so it will not allow. That's the reason it is complaining. So let's put that back in the comment, and okay, so that is done. So only variables you can modify. Now what do you have to do? Let's skip this piece of code. I'll come back to this in a bit, but let's say we start by creating, you remember I told you we need to create a session. So the way to create a session, there are a couple of ways of creating a session, but this is for beginners, this is the easiest way. All you need to do is assign a variable called ses, or you can give any name, and that is equal to tf dot session. That is the session method here, and you create a session object by the name ses. Now what I'll do is I'll skip this as well. There is a purpose behind that. Now let's go ahead and run this piece of particular operation. Remember I mentioned that everything you need to run. So as of now the code has not really got executed. TensorFlow code has not got executed. You only created the graph. So only when you run through the session is when actually the program gets executed. So when you do this, now you see, observe that it is giving an error. Okay, the reason behind that is, remember we skipped these 2 lines of code for variables. Okay, this and then this. Now this is something very important to observe. If you have variables in your code, what I mean by that is, let's say you are not using variables but you have only constants and placeholders, then this will not complain and you will not get this error. But in our case we also have variables. So whenever you have variables, in that case you need to do an initialization, and this is just a standard code. There is nothing that we need to add or modify or anything like that. This is a standard piece of code. You create this name, of course can be anything, you can give us any name, but this global variables initializer is what you need to call tf.global variables initializer. This will kind of initialize all the variables that you may be using. And then again, remember this doesn't execute anything, right? So all you're doing here is you're creating an operation, but in order to run that operation you need to also run this known as run init_op. So this operation you need to run after creating the session. All right, so we executed this. Now let us execute this, and now when I run this piece of code, it will run successfully. Okay, I hope you observed that. So it is, whenever you use variables, these 2 lines of code, one is the operation, you need to create an operation for saying global variables initializer, and then you need to run, before running anything else you need to do a session.run this operation. Okay, again, only if you're using variables. Of course you invariably in all your programs you will use variables. You cannot just write a program with constants and placeholders, so you can pretty much assume that this has to be there in pretty much all the programs. Now again, why this has not been taken care of in the library, that's a different question, but you need to keep in mind. And always remember, if you don't do this for whatever reason, if you've forgotten, you will get an error and the error won't be intuitive. So you need to remember this, that this could be because of the variables. Okay, good. So we have seen how to create a constant, and we have seen how to create a variable, and we have seen that you cannot modify or update a constant, and we have also seen if you have variables that you need to execute or have these 2 lines of code to initialize the variables. And then we have seen that after creating a graph, how to run the graph in a session. And I will show you a little bit more in detail how exactly the graph gets created and how it gets executed. But this was the first very quick code on creating variables and constants. Now we will keep going, and we will also show you, or I will show you the placeholders. But before that, one more small piece of code. So this is how you write a for loop. Okay, so we are saying 5 times you run this piece of code. Now like any Python program, this is nothing different. So you have a for loop and this is indented, that's the reason. And therefore you say session.run update. So this will run 5 times and it will get printed, that's all. So update will run for 5 times. Each time it will come and do this particular operation. That's all we are asking the system to do. So let me just run that and show you. So it will, okay, so it has done 5 times. That's for, it is basically adding, if you recall, it starts from 0, it adds 1 to 0, then 1 to 1, 1 to 2, and so on. So it's nothing but it is generating 5 numbers, 1 2 3 4 5. That's it. Okay, so then you can also have your constants as strings, for example. So you can also work in a similar way. You can work with strings. So most of the computation happens mainly on numerical values. So we normally handle numbers, but there will be situations where you may have to handle strings as well, or text as well. So this is an example of text operation. So you can, similar to numbers, you just create strings or store in constants. Instead of a number, you say hello is equal to tf.constant, and then you assign the string that you want it to be assigned. And then the next one is one more string, which is for world, and then you say add these two. So it is nothing but concatenation of these two words, hello and world. So we will do that. And remember, this is only creation of the graph, right? So in order to actually execute this graph, you need to run the session. Now you need to keep in mind, we don't have to create the session once again, because once you create a session, till you close the session, it remains valid. Okay, so we have created this session here. Now till you say ses.close, it will remain for you. So that's why we did not create one more. So we are just reusing that session, ses.run hello world. So in this hello world, what is the operation that we are doing here? The operation is add these two, concatenate these two. So if I run this, it will print hello world. Okay, now that's string operation. Now we will take a look at placeholders. So this is slightly more complicated and something new even for people who have been writing programs. So, but I'll just explain it with a quick example. First of all, how do you declare or create a placeholder? You just do tf.placeholder, and the p is lowercase. Only in case of variables, the v is uppercase, but otherwise constant and placeholders, it is lowercase. And you just say, because as I mentioned, this is a placeholder that doesn't have any value. So you, unlike a constant or your variable, you will not specify any value. You just say what type of placeholder you want. And very often, most of the cases, it is a floating point. So we just say placeholder of type float32. So this tf.float32 tells the system that it is a floating point. Okay, and then so let me just run this, and then you can do some or define some computation, like for example, b is equal to a into 2. Now remember here right now a has no value, but what we are saying here is at any point later on when a gets some value, then b should be equal to twice the value of a. That's all we are saying here. Okay, and also as I mentioned earlier, we are not yet executing anything, we are just creating the graph here. Okay, so now you have that. Now how do you feed the value or populate the placeholder? There is a certain syntax in which you can populate the placeholder, and you do that using what is known as a dictionary. You're all probably familiar, those with Python especially must be familiar with the dictionaries. So you need to create a dictionary and then pass that in order to feed the placeholder. So in this particular example, if I want to run something, if I want to calculate or compute b, obviously I need to feed the value of a. So the value of a I'm feeding using this dictionary, and I'm saying that a is equal to 3. Now there are multiple ways of populating the value of a, because it typically this won't be just a scalar value like in this case, right? Remember scalar, so it's just one value, one number. Typically it would be a vector or a tensor. Very often it is a tensor. So we will see step by step. So we can start with the very basic example where a can be a scalar. So in this case a is equal to 3. That's what we are saying. Feed underscore dict. In this case, feed underscore dict is the name of a variable, by the way. So you can't give anything else here. So if you just say feed is equal to this, it will give you an error. Alright, so keep that in mind. Either you specify feed underscore dict is equal to and give the dictionary, pass the dictionary, or you straight away, like in this case, this is another format. So let's see. First, let me execute this. It has given 6. Okay, I think let me see if I can clear out this particular cell so it becomes easier to understand. Okay, so it is giving you 6. Let me do that once again. Clear out this and then, okay, and let me change the format. So this is one way of doing it. Another way is you don't even have to specify the name of this parameter feed underscore dict. You just pass the dictionary and it will execute. Okay, but typically this makes the code readable. So that's the reason most of the places whenever you find TensorFlow code, you will see that they explicitly mention feed underscore dict so that the code is readable. Otherwise it can get confusing. So I will also comment this and retain the other format. Okay, so I hope it's clear. So what we are doing here, we are running the operation b, and what exactly is b? B is twice a into 2. So therefore what we are doing, and a has not been, doesn't have any value out here, right? So that's why we are feeding the value of a, and then the operation gets completed. So a gets a value of 3, and then it gets multiplied by 2 because that's what we said here. Therefore b gets a value of 6, and that's what is being fed into result, and that's what is getting printed here. Okay, now as I mentioned, a need not be just a scalar value. It can be a vector with a multi-dimension array and so on and so forth. So let's start showing you examples of that. Again, let me just clear out the outputs. Let me clear this, and let me also clear this for now. Okay, you can also do, before running this, we could also do clear all output clear. It will clear everything, but we'll have to start all over again. So I'm just doing individually. All right. So in this example, we are taking a one-dimension array where rank is equal to 1, and I'm feeding 3, 4, 5. Now let us see what happens if I run this, right? As you can imagine, it gets multiplied. Each number gets multiplied. So the result is 6, 8, 10. Okay. Now, as I said, it can get more complicated. Now let's say this is a multi-dimensional vector. So what happens if you feed this? Okay. So as you can see, this is pretty complicated. Now, but if you feed this again, all you're doing is there is a slight change here again. You can also create your dictionary outside and feed that here. You don't have to directly do it here, like in this case. You see, there are variations of the exact syntax in the way you write it, right? So there is a slight variation. So in this case, you are creating the dictionary straight away here, kind of in line. But here, you created the dictionary separately because it's more complicated. And then you are passing that dictionary here. So I said dictionary is equal to A, and then I'm saying this is what should be the value of A. And I'm feeding that. And then I'm using directly that dictionary here. Okay, so this is equivalent to putting this code here, right? So if we execute this, what happens? Same. So you get, because A was, let's say this is a 3 by 4 by 2, right? So that is 3 by 4 by 2, right? So you see here, this is a multi-dimensional array. So you feed that, and the values you see here, it is 1, 2, 3. It became 2, 4, 6. 4, 5, 6 became 8, 10, 12. 7, 8, 9 became 14, 16, 18, and so on and so forth. Okay, I hope now you got an idea about placeholders. And in real life, what happens is you typically won't create these dictionaries manually. Since this is a quick demo, we did this. You will actually read the data into this dictionary, and then you feed that when you're doing the computation. Okay, so it could be a CSV file, or it could be an image file. So input is basically read and fed in. Usually it is also done in batches, so you don't read the entire thing because there can be a large amount of data. So that is the idea behind having these placeholders, and the way we feed these placeholders, there is a provision, deliberately there has been made a provision for this kind of getting data into the program in chunks. Okay, now in this particular example, we will close the session here, and then I will show you what is the other way of creating a session, right? So now if I close the session here, now if I try to do anything with the session, it will give us an error. So I will probably not do that right now. Now there is another way or another format, and this is a very common way of using the session, but I didn't want to start off with this because this could get a little confusing. A simpler way was to create session saying ses is equal to tf.session, but typically you will do it in what is known as a with block. This is a very common way of creating session. So once you have the graph, you would execute the graph in a session using a with block, and this is the syntax. So you say with tf.session as ses, all right, and then you put all your code here. So what will happen is you don't have to explicitly close the session. The moment this with block gets completed, the session gets closed. Okay, so let's just take a quick look at this example. Now, if we, let me clear this, current output, we clear. Okay, so this is the hello world example. A little bit earlier we did that. So I'm doing with tf.session as session result is equal to ses.run hello plus world, and then I say print result. Okay, so within this with block, I'm doing all my computation and this gets executed. Now let's say I try to run, remember I created a session here. Now if I want to, let's say, do something like run ses.run a, it is giving an error because the session is no longer valid, right? So you cannot, either you have to run this, if you want to run this, you have to run this in this with block, or you shouldn't have closed the session here, right? You remember this, we said session.close. So since we have closed the session, there is no active session, therefore it is giving an error. Okay, now there is a third way of creating a session, but for now I will skip it because that is very, very specific do notebooks and so on, so we will just avoid it. You start with, for beginners, I think the best way is to start with creating a separate session and then writing your code and then closing your session. Now, of course, remember, if you don't do this part, ses.close, it will not give any error or anything like that. Only thing is that it's a good practice and your resources will get released. Otherwise, if you do multiple of these programs, if they are running, then your resources will get blocked. That's the only thing. And to start with, it is simpler to do it this way. So initially when you're doing, you start with this. But as you move forward, as you become familiar with TensorFlow programming, I would recommend all of you to get into this model. Most of the programming, TensorFlow programming, is done like this with tf.session as says. Okay. All right. So that was one book or one page of code that we have done explaining about variables, constants, and placeholders. Now let me explain how the graph works. So in this example, we are going to see how the graph is created, how the graph gets executed, and so on. Okay. Now that we got a understanding of constants and variables and placeholders. Okay. So we will start as usual by importing our library, and as I said, whenever you create a TF or TensorFlow object, there will be what is known as a default graph, and you can get a handle of that by saying get default graph. So let's do that, and you can display the operations. Remember, every node in the graph is considered as an operation, right? So as of now, as you can see, we have not done anything. We have not created a constant or variable or nothing, right? So there is no operation. So by the way, let's do one thing. Let's start with all output clear so that I don't have to again do individually. So I'll just run these two lines of code. Okay. Now, so we have the default graph. And as of now, there are no operations. So there is a method called get_operations, which will kind of display or show what are the various operations that have been performed on the graph. So as I said, to start with, there have no operations been performed. So when I try to display, it's empty. There are nothing is there, no operations. Okay. Now let's see what happens when we slowly, step by step, start writing or building the graph. So my first step may be to create a constant. Okay. Remember, in the previous example, I have shown you how to create a constant in the most simple or the simplest way, which is like constant and then the number, right? Now, a small extension of that is you can actually give a name to your constant. Now again, this need not be the same. I can say a is equal to name and xyz. I can give anything here. Okay, this is just for your reference, but here for simplicity, because there is a purpose why I'm using the same name as the name of the variable, and there are other reasons as well why you would give a name again to a constant or a variable. This is again useful when we are using what is known as tensor board. Otherwise it doesn't have much value. This additional name doesn't have much value. In this our case also, we will be seeing the graph, and that's why I'm using this, but otherwise this having additionally a name usually doesn't add much value. All right, so let's create a constant. I created a constant. Now let us see what's going on in the graph. So I will just say operations is equal to get operations, and if you see here, now you remember here it was blank. Now you see the first operation is showing up, and this A, that's the reason I put here. So it is showing as A, and it says that, okay, you have performed an operation and there is a constant. You have created a constant. Okay. All right. So let's move on. Let's say we want to create a second constant, and this is B. So if I see what are the operations, list of operations that have been performed, you see here there are two of them. So you have operation A, which is a constant, then you have an operation B, another constant. You recall, in the term operation here is not very intuitive, right? So we are just creating constants or numbers or variables, and it is saying it's an operation, but that's a terminology in TensorFlow. Everything is an operation here. Okay. All right. So then what else? Let's say I want to create a third operation, and that is basically adding, this is a real operation in normal sense as well. So let's say I'm creating C, which is adding A and B, and the C value obviously will be A plus B. Okay. Now, if we want to see what is in C, and we say C, you see here, it is not showing 30. it just says it is a tensor and it is of type int32, right? Because we have not executed the graph, we are still only building the graph. I hope this makes it easy to understand. Okay, so we are just building the graph. We have till we do a session and run a particular operation, you're not actually executing anything. Okay, you're just building the graph. All right, so now let us see what are the operations. We have done A, B, and now C. So you will see there are 3 of them, A, B, and C. Okay, now let's do one more operation, which is D. And here I am doing multiplication. Remember we did a tf.add. Now I'll do tf.multiply. And I'm multiplying A and B, and I'm calling this operation as D. So A has I think 10 and B has 20. So D will be actually 200 when we execute it. Right now it is just a tensor and it is of shape int32. Okay, and once again we can see what are the operations: A, B, C, D. And let's do one last operation here, which is E, which is once again multiplication of C and D. Now that C has 30, which is A plus B, and D has 200, which is A into B. So now C into D will be 30 into 200, which is equal to 6000. But as we have seen earlier, that multiplication will not happen right now. So now you have built a fairly simple but operation graph, which consists of A, B, C, D, E, 1, 2, 3, 4, 5 operations. Okay, so you built a small, it's not a very complicated one, but a simple graph. Now you need to execute these operations. So what you need to do, you need to create a session. Okay, so ses.tf is equal to session, and then you can run these session, print ses.run e. Now, am I missing something? Do I have to initialize the variables? That's a question for you. Think and tell me. Do I have to initialize the variables? Then remember, I ran one piece of code. I think you must have got the answer. I don't have to, because I'm just using all constants here. I have not used any variable here, right? So I don't have to execute that piece of code to initialize the variables. So I can just create a session and run any of the operations that I want to run. So in this case, I'm running session E, operation E, right? This operation E. Now I can actually run individually. Instead of doing directly E, I could have run only A, or I could have run B, and so on and so forth. But in this case, I have run E, which in turn will do all the required computations, which is, for example, assigning the value to A and B and C, doing the multiplication and so on. All those operations will be performed, which are required to do the computation of E. Okay. Now, there is a small piece of code that you can use to find out what are the various operations that are there in this particular graph. In this case, of course, it was very easy, very straightforward. I have created A, B, C, D, E. But in normal programming, in real life, this can sometimes help to see what is there in your graph, what kind of operations are going on in your graph. So you can write this piece of code, and it may sometimes help debugging as well. Okay. All right. So I finished my session. What do we have to do? We need to close the session, right? Because I did not use the with block. So I need to close the session as a good practice. So I close the session. Good. So that's how the graph works. I hope it was helpful in understanding how variables and constants and placeholders are created in the previous example we saw, and how exactly you create a graph and then you actually execute that graph. That's the way TensorFlow program works. That's the structure of TensorFlow program. Okay, so now that we understood the structure of TensorFlow programming, let's take an example, and a classification example, and take some real data from outside, external data, CSV file, and try to solve a classification problem. For that, let's first go back to the slides and understand what is the problem statement, and then we will come back. Okay, so what is the case here? We have some census data, and which has all these features or variables, like the age of a person, what class, work class, what is his education, what is his marital status, gender, and so on and so forth. So there are a bunch of features that are available, and we have to basically classify, or not classify, we have to build a model for classifying whether the income of this person is above 50K or below 50K. Okay, so there is actually a label data available. We will then try to build a model and then see what is the accuracy. So that this is a typical machine learning problem actually, but as I said, TensorFlow can be used for doing machine learning as well. So we will, as a simple example, we will take machine learning. So this is how the high level the code looks, and in TensorFlow programming we also take help of regular Python libraries, like for example it could be NumPy, or it could be Scikit-learn, or it could be Pandas in this case. And because before you actually develop, or before you train your model, create your model, you need to prepare the data into a certain format. And sometimes if you're doing machine learning activity, you all are familiar, those familiar with machine learning will know, you need to split your data into training and test data sets. So all that can be done using regular non-TensorFlow libraries, right? So these are like regular Python libraries, Pandas, Scikit-learn, and so on. So we use that and then prepare the data and then use TensorFlow for performing either the machine learning or deep learning activity. Now, so what is the advantage of using TensorFlow? The main advantage is that TensorFlow offers high-level APIs. Right? We talked about that. So in this case, we will be using, I'll explain what is in the slide, but before that I wanted to just show you what is the API that we will be using. So we will be using the estimator API. We will be using the estimator API to create a classifier, what is known as a linear classifier. Now, in order to do that, you need to prepare the data, and you need to prepare the data into a certain structure or format, and the API itself needs to be fed in a certain way. So that is exactly what we are doing before we get into the regular TensorFlow code. Okay, so these slides will quickly show you what exactly is happening, but I will take you into Jupyter Notebook and run that code and show you. So here we are importing the data. The data is, the name of the file is census_data.csv. It's a CSV file, and then there is income bracket is one of the columns, which basically is our target. That is what is used, that is the label rather, but this doesn't have numeric values, so it has the income. So we need to convert that into binary values, either 0 or 1. So that's what we are doing here. And then we are splitting using Scikit-learn. We are doing splitting of the data into test and training, right? So this is a standard Scikit-learn. People, some of you who are familiar with traditional machine learning, and you have done machine learning in Python using Scikit-learn, will immediately recognize this. This is a sklearn is Scikit-learn, and there is a readily available method to split the data into training and test. That's what we are doing here. And then you need to create what is known as feature columns and input functions before you can call the API, estimator API. That's what we are doing here. And there are different ways of creating the feature columns for numeric values and for categorical values, or rather for continuous values and categorical values. Okay, so that's what has been two types we are doing here. We will see again in the code as well. And then you create your model. So this is basically model is equal to tf.estimator linear classifier, and then you're feeding the feature columns, and also subsequently you will call the training by passing the input function, and you specify how many iterations to be done for the training process. And again, this is all typical machine learning process, so there is nothing specific for TensorFlow here. And then you evaluate your model, because this is classification model, so you can again take help of the Scikit-learn to test the accuracy and get the reports, perform the evaluation and get the report like this one. Right, so this is the classification report, and you will see what is the precision, recall, F1 score, and so on. Again, this is a standard machine learning process. All right, so that's pretty much as far as the code here is concerned. Once again, let me take you into our lab, and we will get started with this particular code. Now let me clear out the outputs so that you can step by step you can see the output. So this is our data, and we will actually this is just a display here. The code starts from here. So before even we start with our TensorFlow part of it, as I mentioned, we now remember in the previous examples the data was kind of cooked up. Internally we created some data and we were using it, right? The constants, variables, and so on. Here is a real life example. So you are actually getting data from outside. So before we get into TensorFlow, this is actually regular Python code. So we are using pandas, for example, to create our data frame. So we will import pandas, and then we will basically read our file into a pandas data frame, and this is how the data looks, right? And if you do ahead, it will give you about 6 readings or observations, 5 or 6 observations, and then you can take a look at how your data is looking. So for example, you have age, work class, education, and so on and so forth. Okay, and you see here this last column, income underscore bracket, it says whether the income is greater than 50k or less than 50k. So this cannot be understood, or this cannot be fed into our model, or so that's the reason we need to convert this will not be understood, right? So this needs to be converted, saying okay, maybe less than 50k is 0 and greater than 50k is 1. So that conversion needs to be done before we feed it into our model. So that's what we are going to do as we move forward. So this is the code for doing that. Okay, so we take this and then we define a function and then we run that function. So now we have, wherever it is less than 50k, it will have 0, and greater than 50k, it will have 1. So we have now updated the data. Then the next part is to split our data into training and test data set. So how are we going to do that? We again will take the standard Python library, which is scikit-learn, sklearn library, and we use an existing function there, which is train test split. And what we are doing here is basically splitting the data into, I'm sorry, I need to run this and then this. Okay, sorry about that. So once I run this, what are we doing here? Again, those who are familiar with scikit-learn will immediately recognize I'm splitting this into test and train. I'm saying test size is 30%, so 30% of the data should go into test, and training should have 70%. Okay, so that's all we are doing. 0.3 indicates 30%. So you can, again, this can be individual preferences. Some people do it like 50-50, some people 20-80, and in our case we are doing 70-30. So training is 70 and test is 30. Okay, all right. So we have, so far we've been doing regular non-TensorFlow stuff. So preparing the data so that we can now use for TensorFlow. And in TensorFlow, what we are doing is we will be using the API called estimator. Now estimator, in order to call estimator, you need to prepare what is known as feature columns. So feature columns have to be in a certain format. Basically, it is nothing but the columns. We have to put them in a certain format. And then when we are calling the training, we need to pass what is known as an input function. Again, a certain way in which you need to pass that function. So that is what we need to do before we create the model and run the model for training. So the next few lines will be doing that. Quick look at, before we even get in once again into the TensorFlow code. So this is just showing us what are the various columns, names of the columns of this data. Okay, so that is what is shown here, and this is more for when I was writing the code, I could copy paste from here. That's the reason this line of code is there instead of typing in these values. Okay, good. So now is where the actual TensorFlow action starts. So I import TensorFlow, and now I will use this feature column functionality to create my feature columns. And there is a certain construct how you create the feature columns. Again, probably the details of that is out of scope here, but just that you need to know that we need to create feature columns, and the way you create feature columns for continuous values and for categorical values is slightly different, and that's the reason you have two different blocks. Okay, so for categorical values you need to use what is known as tf.featurecolumn dot categorical column with vocabulary list. And again, within this, again, there are two ways in which you can create for categorical values. One is a vocabulary list where you know how many types are there. So for example, gender column can have only male and female. So in such a case, if there are, let's say, a finite number of values for a given column, then you use a column with vocabulary list. Okay, so and then you say what is the name of the column and what are the possible values. So in this case, male and female. Now there will be situations where the values that this column can have, okay, first of all, it is a categorical column. That means it can have names or some non-numerical values, but the number of values is probably unknown or undefined. So for example, occupation. Now occupation can have any value. It can be self-employed, it can be a software professional, banker, a teacher, doctor. So many possibilities are there, and we don't know in the given data how many occupations have been listed, right? So that is where you use what is known as categorical column with hash bucket, and you specify the hash bucket size. So what this says is there can be a maximum of 1,000 such values. So typically you give a safe number, safely large number, so that you don't run out of these number of occupations. So I think 1,000 is a safe number. I don't think there will be more than 1,000 occupations in a given data. So that's the idea behind it, but that's a judgment call we need to take. What should be the size of this bucket size, right? Hash bucket size. So these are two different types for categorical values for creating the feature column. So we will execute this for all the categorical columns. Obviously you need to know the type of the columns, and that is where, if you see right at the beginning, this information was provided. What is the data type, and you see here the column name and whether it is continuous or categorical. This information is provided in the census data wherever we pick this census data from. By the way, this was picked from online from a government website and we stored locally. So on that website it is mentioned, the details of this data were mentioned, and they have mentioned whether each of these columns is categorical or continuous. So that information we have to use, and we have to create feature columns using this categorical method for the categorical type of columns. And then for numeric or continuous values, you just use what is known as feature column dot numeric column. Okay, so these are all continuous or numeric values like age, education number, capital gain, capital loss, hours per work. These are all numerical values or continuous values, right? So you just say tf dot feature underscore column dot numeric underscore column and then give the name of the column. So once you do that, I think I have executed the previous one. Yeah, this one. Now, so your feature columns are ready, and you need to basically create a vector of all these columns, and we call that as feat underscore calls, which is like a short form for feature columns. Now, as you have seen, I've mentioned earlier also, there are two things that are needed. One is the feature columns and the another is the input function. So feature columns to first create the model, and then to train the model you need to create an input function. So now we have the feature columns ready. Next is to create an input function, and there is a certain way in which you need to, this construct is pretty much a very common construct, so we will use that. So the input function takes these x and y values for training and tests. You remember these are the x train is the x values of the training data set, and y train is the labels of the training data set. So that's what we are using here, x train, y train, and then we specify what is the batch size. Batch size, you remember I mentioned, this is what will say how many records need to be read each time, right? So typically when we are doing the training process, we don't get the entire data in one shot. We do it in batches. So what size you specify here. Number of epochs, in this case we just say none, but number of epochs is again probably the definition is not required here, but at a very high level, how many times the entire data has to be passed through the model, right? So if you have 1,000 records and you pass all the 1,000 records 3 times for training purpose, then you call that as 3 epochs, right? So there is a difference between the batch size and epochs. So when, let's say we have 1,000 records and you're saying batch size is 100, that means there will be 10 batches, right? So if you take 10 batches, then that is one epoch gets completed. Okay, then the training obviously doesn't get completed in one round. Okay, so you need to pass this data again, maybe a second time or a third time, till you get the right accuracy. That is known as epochs. Okay, again, if you need more details about this, you may have to go through the machine learning tutorial. I think it becomes much clearer. Okay, so you have your input function as well. Let's execute that. Okay, and now we are ready to use the API, right? So what will we do? We will create the linear classifier using tf.estimator.linear classifier, and this guy needs feature columns, right? So that's why we did all that, so much of manipulations to create this feature columns. So we have feature columns, so we pass that and we create our model. There may be a few warnings, don't worry about that, so we will just ignore that. And now we use that model, and what we did is we created an instance of the model. We have not really run anything, we just created an instance of the model. Now we will create the node for training. So model.train, and this needs the input function. Remember, we created the input function, so we need to pass the input function, and then we say the steps is now telling how many iterations this training has to be run. So we are saying 5,000, and it will probably take a little long, so we will, okay, but that's fine. I think we will leave it 5,000. Sometimes if you have probably a less powerful machine, you can cut it down to maybe 1,000 or something like that. But in this case, I have a fairly powerful system, so I think it shouldn't take much long. Let's go ahead and give a couple of minutes for it to get over. Okay, so let us go back. Yeah, I think this is done. You see here the hourglass has disappeared. That means this computation is done. Yes, okay, this is done, right? Saving checkpoint for 5,000. That means it is done. So training is done. So now what we have to do? We need to do the evaluation. So again, this is a standard machine learning method. So methodology rather. So training has been done with the training data set. Now you need to evaluate using your test data set. So that's what we are doing here. For example, you see here x_test is the test data set. Remember, we used scikit-learn to split the data into training and test data set. So x_test. And a quick question, why are we not using y_test here like we did in case of training? Obviously, we are expecting the model to predict the values, y values, right? So that's why we don't pass the y values here. All right. So let's execute this for doing the evaluation. All right. And then we put them in a proper format because the output doesn't come out in a proper format. So we put it in a list format, and then we can just check. Yeah, so this is done, and we can check what is the first element in this, what is the probabilities, and so on. So it's just a quick way to see if the values are there or not. You can take any value here, right? Any element here. All right, now that the testing is done, what we need to do, again, we will probably put them in some kind of this is more of a formatting thing. We will just run through quickly, and then we will use once again scikit-learn for finding out the accuracy and so on, because scikit-learn offers what is known as a classification report functionality. So we will use that and find out how well our model has performed. So you see here again, people with machine learning background will be immediately able to recognize this. So it gives us what is the precision, what is the recall, and F1 score. This is pretty much like you're getting like almost 85% accuracy, which is pretty okay. And there are other ways to increase the accuracy. For example, you can run the training for more iterations. That is one way, get more data and so on and so forth, or use this is a linear classifier. We could have used a non-linear classifier and so on. So again, multiple ways of doing it to increase the accuracy. But the idea here was to quickly show you a piece of TensorFlow code, and that's what we have done here. All right, so let's go back to our presentation and let's see. So what are the key takeaways from this session? We saw what is at a very high level, what is deep learning, and what are the various libraries that are available for writing deep learning programs. And then we focused on TensorFlow. We saw what is TensorFlow, what are the elements of TensorFlow, how to write a TensorFlow program, what are the elements of a TensorFlow program. what are the various types, storage types like variables and placeholders and constants, and what is the difference between them, and how to construct a graph and execute a graph. So we have seen all of that, and then in the end we went through a case and executed a piece of code for classification. So with that, I hope this was helpful. We come to the end of this. Thank you very much for your attention, and if there are any comments, please put it in the comment section, and if you have any questions, provide your email ID and we will try our best to respond to your queries or questions. Thank you once again. Bye.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.